Hello everyone, welcome to the next session on application of Bernoulli's principle. In this session, we will see about the third application, which is Pitot tube. Pitot tube is a device used for measuring the velocity of flow at a point in a pipe or a channel. It is based on the principle that the velocity of flow at a point becomes zero. The pressure there is increased due to the conversion of kinetic energy to pressure energy. The Pitot tube consists of a bent 90-degree tube. It is made of glass. You can see flow taking place and the Pitot tube is inserted into the pipe. At this section 1, the velocity of the fluid is V1. At this point, the velocity will be V2. When the flow takes place towards the Pitot tube, since there is no other exit, hence the velocity at point 1 is going to be more than the velocity at point 2. At point 2, it becomes approximately equal to the velocity of this pipe. At this point 2, the velocity becomes approximately equal to 0. Now when the velocity becomes 0, at this point the pressure is going to be very high. This pressure is called as a stagnation pressure. With the help of this pressure, the liquid is rushed through the Pitot tube and it rises to a particular height. Let me mark this height as small h and this height as capital H. For theoretical value, the V1 is calculated as root of 2gh. This can be derived by using Bernoulli's principle, which can be applied at section 1 and 2. I have just given you the formula over here. The velocity at point V2 is equal to 0. This is also called as stagnation velocity. Actual velocity V1 is calculated as CV root of 2gh. When I say actual velocity, it means there will be some losses in the system. So this term CV comes into picture. CV is called as the coefficient of Pitot tube. Velocity at any point V can therefore be calculated as CV root of 2gh. This velocity V is called as central velocity. Central velocity means along the center line of the pipe or a Pitot tube here. You have just seen an example of a simple Pitot tube. There are few more types of Pitot tubes, in which the most important one or the most used one is called as a Pitot static tube. Now what is a Pitot static tube like? Suppose this is a pipe through which water is flowing. This symbol indicates free surface of water. When the direction of flow is this way and I have a small tube over here, at this point you will see the same feature which you have seen in the previous diagram. So at this point the velocity will become 0. You will have stagnation pressure over here. The water will rise from this end by the help of stagnation pressure. So from this limb of the manometer which is connected will show your stagnation pressure. Now in Pitot static tube, apart from one tube, there is another concentric tube which is attached. This tube is going to measure your static pressure at this zone. So this end you see static pressure and this end you see is stagnation pressure. There is a formula for stagnation pressure, static pressure and dynamic pressure. This is the relation between the three. Stagnation pressure is equal to static pressure plus dynamic pressure, or I can say that dynamic pressure is the difference between stagnation pressure and static pressure. Since this is in terms of pressure, I can write it also in terms of pressure head by dividing with rho g throughout. Since the fluid flowing through the pipe is water, hence the value of rho will remain constant. So I can write this equation as H stagnation is equal to H static plus H dynamic. Now there is one more formula which you can use, that is H is equal to X into SH upon SF minus 1, which we have already seen. Rate of flow of water Q is given as A into V bar. A is the cross section area of the pipe and V bar is called as a mean velocity of water. This is very important here. V bar is called as mean velocity, which means we calculate the average velocity of the particles. There are various applications of this Pitot static tube. It is used at the end of your aerofoil, which is used for measuring the air pressure. Now let's see some numericals on Pitot tube. A Pitot static tube placed in the center of a 300 mm pipeline has one orifice pointing upstream and the other perpendicular to it. The mean velocity in the pipe is 0.8 times of the central velocity. So I have written here the diameter of the pipe D is 300 mm converted into meter. The mean velocity V bar is equal to 0.8 times the central velocity. Central velocity is indicated by small v. Find the discharge through the pipe if the pressure difference between the two orifices is 60 mm of water. The pressure difference is given as 60 mm of water. Since it is given in terms of mm of water, hence I call it as pressure head. I have converted into meter. Take the coefficient of Pitot tube as CV equal to 0.98. So the value of CV is given. We have to find the value of Q. Q is equal to A into V bar. For calculating V bar, we have to calculate the value of small v. V is equal to CV root of 2gh. All the values are known, hence I get the value of small v. When I substitute this value in this formula, I'll get this value of V bar, which is the mean velocity. Area can be simply calculated as pi by 4 d square. Area and V bar both are known, so you can calculate the value of Q, which is 0.06 meter cube per second. Let's take up another numerical. Find the velocity of flow of an oil through a pipe when the difference of mercury level in a differential U-tube manometer connected to the two tappings of the Pitot tube is 100 mm. Manometer reading X is equal to 100 mm of mercury. I have converted in terms of meter of mercury. Take the coefficient of Pitot tube 0.98 and specific gravity of oil is given as 0.8. CV is given as 0.98. Specific gravity of oil S0 is given as 0.8. We have to find small v. For calculating V, we have the formula CV root of 2gh. For calculating the value of h, we know the formula x into sh upon s0 minus 1. I know all the values. I can get the value of h in terms of meter of oil. When I substitute this value of h over here, I'll get simply the value of V. Let's take up another numerical. A Pitot static tube is used to measure the velocity of water in a pipe. The stagnation pressure head is 6 meter and static pressure head is 5 meter. So stagnation pressure head HST is given. Static pressure head HS is given as 5 meter. Calculate the velocity of flow assuming the coefficient of tube equal to 0.98. Here CV value is given as 0.98. I have to calculate the value of V. We again know the formula V is equal to CV root of 2gh. Here for calculating H, I will use the formula H stagnation minus H static. HD is 1 meter of water. Now this HD is nothing but H. In this formula, when you calculate velocity, this H is obviously dynamic head. So when you substitute the value over here, you get the value of V as 4.34 meters per second. Let's go to the fourth numerical. A submarine moves horizontally in sea and has its axis 15 meter below the surface of water. A Pitot tube properly placed just in front of the submarine and along its axis is connected to the two limbs of a U-tube containing mercury. The difference of mercury level is found to be 170 mm. So I get the first data of manometric reading, which is 70 mm of mercury. I have converted in terms of meter of mercury column. Find the speed of the submarine knowing that the specific gravity of mercury is 13.6. So specific gravity of mercury is given as 13.6 and that of seawater is given as 1.026. With respect to fresh water, I have to calculate the value of V. Again, you know the formula V is CV root of 2gh. For calculating H, I will use this formula x into sh upon sf minus 1. I substitute the value of x, sh, sf. I get the value of H as 2.0834 meters of water column. When I substitute this value of H here, I get the value of V as 6.393 meters per second. You will observe that I have taken the value of CV as 1 since it is not given. If you want, you can assume the value of CV as 0.98. Let's take one last numerical. A Pitot tube is inserted in a pipe of 300 mm diameter. The static pressure in pipe is 100 mm of mercury vacuum. So the diameter of pipe D is given as 300 mm, which I have converted as 0.3 meter. Calculate the area by using the formula pi by 4 d square. The static pressure head is given as 100 mm of mercury. Since it is written vacuum, I am attaching a negative sign here. Converting into meter, I get minus 0.1 meter of mercury. The stagnation pressure at the center of the pipe recorded by the Pitot tube is 0.981 Newton per centimeter square. Now here, the stagnation pressure is given as 0.981 Newton per centimeter square. So I am converting in terms of pressure head by writing 0.981 into 10 raised to 4. This makes it to Newton per meter square, and when I divide it by rho g, I get the value as 1 meter of water, which is HST. Now calculate the rate of flow of water through the pipe if the mean velocity of flow is 0.8 times the central velocity. The mean velocity v bar is given as 0.85 times the central velocity. Take CV as 0.98. You have to find the value of Q. Q has a formula A into V bar. For calculating V bar, we need the value of small v, which is CV root of 2gh. For calculating h, it will be stagnation pressure head minus static pressure head. I get the value as 2.36 meter of water. When I substitute the value of h in this formula, I get V as 6.6685 meters per second. When this value of V is substituted in this equation for calculating V bar, I get the answer as 5.6682. And when this V bar is substituted back in this formula, known the value of A, which I have calculated, we get the value of Q as 0.4006 meters per second. If you want, you can convert this into liters per second by multiplying with 1000. In this session, we have seen the basic concept of pitot tube and its numericals. In the next session, we will start with the next topic of forces on bend. Thank you.